Alright everyone, we're now at the desktop of the workstation in my lab. The right hand side is from the ADC, the analog digital converter. You can see I have 8 channels, laser displacement sensor 1 and 2, the 12 volt main power. When that comes on I get a signal. Now that's the 12 volt main power going to the main amplifier. Channel 4 is the ambient RF in the 2.35 gigahertz to 2.5 gigahertz frequency band. Channel 5 is the calibration coil. That's whenever it turns on, I'll know, and when it turns off, I'll know. The channel 6 is the interior temperature of the enclosure. I have a thermometer inside the enclosure, which goes to the ADC, and that gives me the temperature inside. 7 is the push-to-talk PTT. That's basically RF on, RF off. It's the amplifier, I think, is based on some kind of CB radio, and so, in order to talk, you push to talk, and so that you'll see is actually, it floats high. When everything is turned on, you'll see it floats high, and it has to be pulled low, it has to be grounded in order for it to work. So that's how push to talk works. The 8th channel is the amplifier temperature. I'm still working on this a little bit. I don't have the engineering units set up correctly or at all, so I just watch the voltage go up or down. And this only works whenever the 12 volts is supplied to the main amplifier. Over on the left-hand side, this is the synth NV2 that controls for the signal generator, and the power detector are here. Down below, you can see I have it at, you have it at 2.407 gigahertz right now, which is the resonant frequency of the cavity I have mounted in the test rig right now. Down below that is the relay control. This is where I control power to the main amplifier. I control the push-to-talk function. I can turn the laser displacement sensors on and off, and I can turn the calibration coil on and off. I'm working on getting all of this automated in LabVIEW so that I can put each of these on timers and run identical experiments and then end up averaging the results at the end. But this little control works fine for now. I can show you how this works. So we're going to first of all turn on the laser displacement sensors. You can see they take a few seconds to sync up, and then there they are. And you'll notice we're very, very stable here. Not a lot of movement at all. Next is we can turn on the power to the main amplifier. This is going to that's idle. The amplifier draws 0.3 amps. It's whenever you turn on the push to talk that it goes up to 6.9 amps. And you can see that the push to talk went down right here because that's grounded. It runs high and then it's grounded. And now you can also see the temperature of the amplifier is rising. Now there is no RF in the system right now because we don't have it turned on over here. Now I'm going to turn off the push to talk. Now what we're going to do is we're going to go into the detector. We're going to turn it on. Now there shouldn't be anything because there is no power. We're going to turn the RF power on. Now since we're in resonance right now, we're going to have to drop out of resonance. Oh wait, I got to push the push to talk. I forgot to push the talk. All right, so let's do push to talk. There we are. So now let's go into resonance. Let's see if I can get us into resonance. Where was he? Where were we? Where are we? We're getting there. There it is. Okay, so yeah, it's moved. Temperature has moved it. There we go. Boy, it's not tuned very well right now. I'll have to go in there and tune it a little bit better. And so that's sort of where we are. I have to, of course, tune it occasionally. It's gone through a couple of heat cycles, so it's way out of tune. Let's see, we could actually, let's go ahead and start the network analyzer and see what we could find close to it. Okay, so there it is. Let's see, we have to add some external attenuation just to get it up to the top here. There we go. So you can see I'm only getting, with this particular tuning, I'm only getting about minus 24 dB. Hold on, let me increase the number of, oh, there we go. Oh no, we're actually doing pretty good, minus 34 dB of return loss, or 35, probably more like 34. Yes, it looks like something like minus 34 dB of return loss. Now here's an interesting thing you can see over here too, where we're picking up the ambient RF. You can see it going in and out of resonance, in and out of resonance, which I thought was pretty cool. So, that's sort of how the whole thing is controlled. And if I wanted to really ramp up the power, I would do so right here. I could ramp it up. Of course, that's not what I want to do. If I wanted to do a test, so now you can see that the RF is sort of returned to normal here. Now if I wanted to do a test, I would run it through the detector. There we go. Now you can see we're at sort of maximum return loss right now. And I could increase the power right now. In fact, we could just go ahead and do it. In fact, let me record. We'll save it as 001. And recording time, hours. I don't think I need hours right now. Alright, I think that's good. Alright, so we're recording now. And let's just crank up the RF. Alright, now we're going to move this in and out of resonance. And RF off. We're going to do push to talk off. Main amplifier off. Stop the recording. And LDS power off. And that's pretty much it.